Next time you draw a 30, 60, 90 triangle, I want you to think about the two perfect arches that are going to fit onto the diameter, the hypotenuse. Because whenever the diameter is 1, the opposite side is equal to the radius of the ball, which is 0.5. And 0.5 squared is 0.25, a quarter. And this side adjacent, which is the diameter of this circle, whenever its measurement is 0.866025403.842, and when you square that value, you get 0.75. That's this section of this circle and 3/4 of the diameter. So you got 3/4 and a quarter, and it adds up to equal 1, which is the diameter. This 30-degree angle right here reflects 60 degrees onto the diameter of the circle, the hypotenuse. And this 60-degree angle reflects 120 degrees onto the hypotenuse diameter. Take this 45-degree triangle inside the ball, for instance. Whenever the diameter is 1, this opposite and adjacent is equal to 0.707, When you square this measurement, it equals 0.5, which is this section of the circle. And the arch takes up 0.5 inches, half of the hypotenuse diameter. And it always runs through the same degree portion of the circle. So the biggest circle, if this is 0 degrees, this is 45 degrees, and you see this leg runs through the 45-degree position of the circle. Well, if this was 0 degrees, this is 45 degrees. It's the same section of the circle. So whenever we square 0.5 and get 0.25, this is the 30-degree section of the circle. Just like in the biggest circle, this is the 30-degree section of the circle. The equilateral triangle inside of the ball, the main circle, balances the circle. So dividing the circle is the same as dividing the equilateral triangle. And the equilateral triangle is created from this adjacent diameter right here. And actually this portion of the circle is equal to the equilateral triangle height. And whenever you take the diameter and multiply it by the equilateral triangle height, it will equal the equilateral triangle length squared. And the radius squared, whenever this is 1 and the radius is 0.5 and its square is a quarter, this length, this is the distance that separates the diameter from the equilateral triangle length. So that's how far it's separated. It's equal to radius squared. That's how important it is.